Hey everybody, this is Derek Goodwin from P9 Cam Solutions. Welcome to our regularly scheduled Friday Lunch and Learn session. Tim Paul will be presenting today, Tim Paul from Autodesk. We also have on the panel today, we have CJ and Wayne Griffenberg from Autodesk, and we also have Michael Witten from P9 Cam. So we've got a lot of power in the back room today to help out if you guys have any questions. What we're going to cover today is productivity tools. Speed of programming is one of the most important features we feel in HSM, so we want to start to highlight this and show you guys how you can use these tools to move along faster. So we're going to go over defaults, templates, and expressions. It's kind of a geeky session today for those of you who really want to dig deep into the software. So Tim, if you're ready, let's get started.
Yeah, hi Derek and everybody. Thanks for joining us. This is probably one of my favorite topics about HSM. I think the hope is as you program along, if you're changing anything more than you find that you're kind of consistently changing, whether it's a rapid height or radial depth of cut or something like that, you should set a default. So think about your shop's best practices and try to set your defaults, make some templates, and you'll find that now you can start using that brain power of not forgetting to change a rapid height or radial depth of cut. Now you can start thinking about other things, better ways to machine, better ways to hold your parts, things like that. So we'll do a quick job overview of this. It's basically like electronic housing or little aerospace, different kind of housing. Part of my background, so it's probably hits my heart a little bit. So you have some cavities with different levels. You have, I think it's well over 150 odd 80 tap holes. They're all 3 different Z levels, but they're also 3 different thread depths. So it could be a lot of selections if you don't have a nice template set up. So I'll show you how to set up a template to spot drill, and tap. I think it's 7 mouse clicks it takes to do all of those holes. So let's jump right into it. Another thing I was going to show with this part, I'm kind of reading my notes real quick. The way this part's set up, you're going to either machine it in, first operation, second operation. We'll use some 3D toolpaths to get these angles. But it could be a 3 or 4 operation depending on how you want to approach those angles. The back side has some engraving, so I'll show you how to set up the template so you can, I think it's like 4 or 5 mouse clicks to do an engraving on that feature there. So I think it's time to jump into it. So basically what we did with this part is we faced it, we roughed it with a 3D adaptive toolpath, we did an outside finish pass, and then we did a 3D horizontal to finish all the horizontal surfaces. We did a 2D contour to go in with a wear compensation to finish the walls. And then I use a flow toolpath to get a nice finish on these angles here. And then we just drilled the holes. I did a blind chamfer here, so I call it a blind chamfer at least. It's when you're chamfering up next to a wall. Later on, I'll show you how to set up the default, because that takes a little bit of selections and mouse clicks to get that set up right. And then that's kind of my favorite, being able to drill and tap and spot drill with only a handful of mouse clicks. So here we spot drilled and tapped, and then we flip the part over. We face off the material we're just holding on to, and then we're going to engrave that there. So here's what I'm going to do now. I'm going to reorient the part, and then I'm going to keep these alive so we can kind of compare what a defaulted face is versus a face I want. So I'm going to hit, excuse me, I'm going to hit Control D on my keyboard to duplicate that entire job. And that's something to think about if you're really programming a lot. Anything you're using a lot of, maybe try to remember these little keyboard shortcuts. less you got to move your hands around, the less you got to, at the end of the day, those little things add up pretty quick. Especially if you're using a space pilot, you're not having to go back and forth between your space pilot and your keyboard. So I'm going to hit Shift-D right here to make this job my default. I'm actually going to just delete all of those tool operations. So now we can look at how the new job that we're going to do compares with what I already programmed. So right now we're going to do a face milling operation. So I'm going to right click in this area, and that's another thing to think about. I think a lot of people are used to seeing this kind of menu up here. I like to use the smaller buttons because most of my, I try to minimize my mouse movement and my clicking. So if you're going from here to here, it is a lot less movement than having to jump up here, down here, over here. So I right-click in the gray space and do a new operation. And then we're going to do a 2D milling and a face mill. So then I'm going to, from my library, I'm going to pick this face mill here and select. Generally, all you should have to do for a face mill is hit OK. And as you see, it brings down and faces that material off. You might be able to get away with it on this part because we got more material than I want to face off with my face mill. But if this was 2 inches thick, pretty good chance you don't want to face it all off in one pass. So if you can see the way I would normally approach a facing, I don't have any real need to ramp in like that. But if you do, then you set your defaults that way. I personally would like it to just come in, feed over, feed off the stock, feed down, feed over again, and if I zoom in here, you'll see a 10th finish path. I actually cut at a slower feed rate to get a better finish. So we're going to show you how to go from this to this. And then the important part is how to make that your default, where you end up getting this toolpath with just, I think it's 4 or 5 mouse clicks. So, and that actually goes from having to edit this to this. I think it takes about 28 mouse clicks. So once you get that default set up, it's 6 mouse clicks. So let's go in and right-click and edit. I think the first thing I want to do, I actually already set up my height default, so I don't need to worry about that. You can see here it goes from the top of the stock and it finishes at the top of the model. Radial depth of cut is good. Really what I want to change is I want to add multiple depths of cuts. If you look at the other one, this was turned off. So we want to have multiple depths of cuts, and then in this field here, when you're setting your defaults, I always recommend making an expression in these different fields and make them to kind of what your normal intent is going to be. That way when you change your tools, your default applies your intent for different length tools, different size tools. So I'm going to edit the expression, or normally I would hit F2. And then you can see on what I did is I wanted my max depth of cut, I wanted to be 75% of my flute length. So on indexable tools, when you've got little inserts, you generally never want to cut right in the screw part of the insert. So that's usually in the middle. So on this face mill, you're going to want to cut it like 40% or 75%. You can be below it or above it. So in this case, I'll set that at 75% of my flute length and calculate it out to 3/16 of an inch. So right here, I'm going to right-click. The way you make that your default is you right-click inside that window, and you just make that your default. So it's that easy. Same thing for this. I want my finished pass to be, let's change that. Let's make it 15 thousandths of an inch. I'm going to right-click and make that my default. And this field is the finish feed rate. If you hover over it, it'll tell you that little tooltip pops up. And in here, I'm going to right-click there. I'm going to edit that expression too, because I want to actually feed it slower than my what I would consider my roughing face milling speed. So in here, I did cutting feed rate times 0.5. So it's going to give me 50% of my roughing feed rate. And if you tab out of that, it'll calculate it for you. So now that I have that set, I want to make that my default as well. So I'm going to jump over to the way you're gonna. So this isn't right mouse click selectable, right? So anything in these white fields, you can just right click, make that your default. But you can't right click on this drop down or checkbox. So the way you're going to make this your default is you're going to use this compare and edit feature. So we're going to turn on multiple depths over in the compare and edit field. So I'll show you how to do that now. So we're going to hit OK. And then in this, I'm going to right click on this face. I'm going to compare and edit. You get all kinds of awesome stuff in here. But for right now, we're just going to do, I'm going to start typing down here in this little box. I'm going to MUL for multiple. And it pops this up. And you can see your different options here. And we do want to turn multiple depths on. So we're going to turn that on, or it was already on because I changed it over in the UI. So I'm going to right-click on that, and I'm going to make that my default. So now that, we'll show you in a minute, that's going to be my new default on the next facing operation. So I'm going to right-click and edit there. Go back to the Passes tab. I think everything's good. Let's go make sure that finishing step is set up right. So let's right-click, compare and edit. Do finishing step is set to yes, and we'll make that our default as well. So the last thing, if you noticed, I didn't ramp in here. I just had it come straight down because I didn't want this move, because that's off of the material anyways. We already have it set up to where it's coming down off of the stock. So we want to set that up so I don't have any wasted moves over there. So we're going to go to the linking tab. And this was turned on. These were turned on. No, I'm sorry. I'm actually reading something else. Sorry. So what we're going to do, this had a measurement in it. I'm going to turn that to 0. I'm going to make that my default. So make default. So let's see how I did. Let's give me the test. We'll delete this. Yes. And then now let's go in and add a new facing operation and see if that's what we actually got. We're going to do right-click, edit in the gray space, new operation, 2D milling, and face. I'm going to grab a face mill. We're going to hit OK. So as you can see there, now we have both facing operations look the same. So it took 6 mouse clicks to get that the way we wanted. If that's your best, your intent to face most things that way, you should be setting things up to where the only time you're changing something is during the exceptions and not the norm. Does anybody have any questions at this point?
Hey, Tim. We do have a few questions coming in here. So let's see. Does the percentage value, does the percentage value work across all tools when you're editing expressions?
I want to make sure I answer that correctly. Yeah. So and you definitely can. They have what I call dumb values that are just set as defaults. So if we go in here and edit this expression, it's just a number that it just remembers. But you can use it for a lot of things. You can use it for depth of cut in relationship to flute length. And then here, so this is our what do we call this? Our step over. So if you right click in here and edit the expression, there's a longer formula here. But what this does is it takes into consideration your bullnose radius of the tool. And then it's going to step over 95% of the tool diameter. So we can change that to like 45 and see what we get. But yeah, for the most part, I mean, I use it for drilling. My pec depth, so I'll use it, and we'll show you that in a minute. I'll use it for each pack. I'll set up at 25% of the tool diameter, and then fully retract after it gets to, say, 4 times the tool diameter. So we can go over that. But does that answer the question?
It does, yeah. And then Chris responded, thanks. So that answers his question. So let's see. I've got a question coming in from Mike. Can we save default files like one for steel and one for aluminum?
Ooh, that's an awesome question. I don't think right now we have that set up, but we are working on a new tool library that might be able to integrate stuff like that in there. So where you set up, tools for steel or brass or whatnot.
Okay.
I think with this, yeah, I can keep rambling. What was the next?
Well, and CJ, one of the Autodesk panelists, just kind of typed in templates. So templates would be the answer for that. I think we're going to get to that in a couple minutes. So perfect.
Yep.
So let's we'll knock out a couple more questions here, and I'll let you get back to it. So is there, and I don't know if you're going to have an answer for this, but we'll throw it out there and we'll start working on it. Is there a list of expression options or values online somewhere?
Can CJ back me up on that one? Because I haven't looked for one, honestly.
All right.
CJ's a programmer type guy. He probably just has them all memorized. But we should, and we'll see if we can find one.
Okay, so I'm going to work with CJ here. He's doesn't have a functional mic right now, but he's saying open an operation.
Excuse me. It's open an operation. I'm sorry. Okay.
Click in the gray space.
Down here?
Yeah.
Okay.
Right click.
Okay.
Copy parameters as text. Open the text doc and paste.
Holy cow. Look at that. TJ just changed my life.
Mine too. That's fantastic. So there's the value in having a strong backup crew on the panel. So thanks, CJ. Amazing. Those are the parameters. Good question there, Brian.
Honestly, that was a great question. Honestly, what I just have always just edited the current expression. And I probably use more of the simple ones. Tool underscore diameter times the percentage of the tool diameter I want. So I'm definitely going to be hitting up all of these so I understand them better.
Right. So while you've got that there, Tim, because there's a little sequence there to memorize, why don't you, after the webinar, save that file, email it to me, and I will send that out to all of the attendees here today, so everybody will have that list handy.
Right.
Okay, so let's see.
Okay.
And this is probably a similar, actually very similar question coming in from Adam to what Mike had asked. Do you have different defaults, or can you have different defaults for different machines, a wood router versus a horizontal mill? And I think templates is going to be the answer to that question. Yeah.
Yeah. So think about defaults as your most common practices. An example would be base milling, with your height tab. The software comes with probably pretty decent defaults, but your retract height is at like 400 thousandths of an inch. I generally leave it at 0. So if you're finding that things like your retract height, you're always hitting 0. Say on face milling, I pretty much always set my top as the top of the stock. And I pretty much always set my bottom as the top of the model. So if you're, that's pretty much the general go-to. That's the stuff you should be setting as default. Now, if you have, some common jobs that, like steel, you have a common, steel parts that take a 1/2 inch rougher and a 1/4 inch finishing tool. You can save as many things in any template as you want. And I'll go over templates here in a second. So.
Okay, and I'd say let's roll right into it. So we're okay on questions for now, but everybody else out there, it's a lot more fun for us when you are asking questions. We get a little bit of interaction. As you just saw, we learned something new we didn't even plan on. So keep them coming. And Tim, I'll let you keep going.
So sticking with the compare and edit topic, let me expand this just a little bit. Another good tool for that, since we're just in there, another good tool for compare and edit is if you want to change something on all of your tool operations. We can all think of times when, say we want to turn the coolant off, we want to turn just the air blast on. If you have a job where, you have, because generally the coolant is tied to the tool, right? You set your tool library up to be flood coolant for that tool. Maybe you want to turn it to where air blast is on for everything. You can highlight everything you want to change together, and that's where you would go compare and edit. You can come over here to coolant, and you can edit all, or you can edit each individual job as you want. But say here we wanted to go, air. I want to turn the air blast on for all the jobs. So you could just change all the jobs. Say another scenario that I've actually done plenty of times is you program, and then you realize, this probably isn't a good example for the part, but you realize, oh, I'm going to have to put a big clamp somewhere, and I want all my rapid heights, my retract heights to go up and over that. So same thing there. If you want to change all of one of your heights, something on your heights tab, you could highlight everything you want to change and go to compare and edit. Come down here and start typing heights. So what height do you want to change? Your clearance height? You could just change it for everything. So keep that in mind if you ever find that you have some clearance height you need to change, or anything you want to change multiple things of, even if it's two. You just highlight both and go right-click edit, or right-click compare and edit. So keep that in mind as well. Let's kind of work down through this here. So another thing I use, let's use for compare and edit, a good example would be the factory default for 2D contour. Let's make a new 2D contour here. We're going to do 2D milling, 2D contour. So we want a face or a side mill around the profile here. We're going to do that with tool 8. Factory default for the diameter compensation is in computer. So you're not going to get a G41 or G42. You're just going to get, you're not going to be able to compensate for that tool. So if your part dimension is off, you won't be able to compensate it in the controller. But if you can see here, I already programmed it where I manually came over and turned on wear compensation. So this is however you want to set up your job, whether it's in the controller or in the wear. So I generally set it to wear compensation. And now I want to make that, because it's a drop-down field, I want to make that my default. Because anything I change more than a couple times, I only want to try to set it as my default. So this is a really good example of why you would want to make that your default. So that's where we're going to right-click, compare and edit, and we're going to start typing compensation. So same thing here. So compensation direction, do you want it on the left or the right for fine milling versus convention? And right here for compensation type, that's where you can change it in compare and edit, or you can make that your default. So I'm going to right-click in that field and make that my default. Okay. And now if I delete that and I do another 2D contour around there, I'll show you how 2D milling, 2D contour. Let's grab tool 8. We'll just grab that geometry there and hit OK. Oh, I forgot to show you. The wear compensation is kept as your default. So keep thinking about your intentions. If your intention is to do 2D contouring most of the time with your wear compensation on, then that's a good time to set that as your default. So working down through the job, we did that. So what I did here is I machined the outside of the part with wear compensation with my tool number 8, which, if you look, is a 1/4 inch, 3 foot, 1 inch length of cut end mill. That's for MA Ford. I came down after that and did a 3D horizontal to finish all my horizontal surfaces in the V direction. But if you look, I did used a shorter end mill because I didn't need the length as I did for the outside. And then on the inside, I used the shorter end mill to machine all the inside. So let's say we want to change that. Here's another little trick that I like. So later on, we decided we actually don't want to do another tool change just to do these 2 moves. So what you would do there is you left click on that 2D contour, and you're going to hold the shift key, and then you're going to, no, I'm sorry, I was showing you something else. So forget I said that for a second. You're going to expand it, and then you're going to left click on the tool. I'm sure CJ and some of those guys are laughing at me right now. So you're going to expand that, left click on the tool, and then this is where you're going to hit shift. And now you're going to drag the tool down to there. And you're going to drag that tool down to there. And you can see how tool 8 now populated those. And then now you're going to want to generate those tool paths. So that's a really quick way. You know, at my previous job, it wasn't uncommon to have, 100 different tool operations, and then by the time you get to the bottom, you're like, I really just want to change these few tools over to the same tool I did before. So that's a good little tip for doing that. Here you can see, this is something to keep in mind for guys. Sometimes you just need to kind of open your thinking a little bit. A lot of people are scared of 3D toolpaths. CJ recently just did an awesome video for Don't Be Scared of 5-axis. Well, we could easily do the same thing for Don't Be Scared of 3D toolpaths. 3D toolpaths are super easy to add. As you can see right here, just did a 3D toolpath to finish machine these surfaces so we didn't have to turn the part up on its side and machine the ends off. So keep that in mind. I mean, this is a really easy operation. Basically you just do a new 3D milling, and I did a flow tool path, and there's a couple different ways you can do it, but you really just select those surfaces and tell it how many times you want to step over, and it just does a nice little 3D tool path to finish those up. So that was that. Working back through the job, I don't need to show you anything about this. This is just a drilling operation. Actually, we'll go back and talk about this actually for a second. We're going to right-click and edit and see how I drilled it. So I did it with just the drilling. The drill bit is it's actually an MA Ford 5X drill, so it can easily drill that in one shot. But let's say we wanted to do a chip breaking tool path. So it's going to make little tiny packs with short retracts just to break the chip. This is where I would add an expression. So the reason I brought this into this on drilling is so I can show you how to set up some of these things. So if you go in and edit the expression, you can see my expression is set up to do these little pecks at 25% of my tool diameter. So each little peck will be 25% of the tool diameter. And then the accumulated peck depth, so take these little pecks, partial retract, and then when it gets down to this distance, it'll fully retract, pull all the chips out, and then head back in. So here it does 2.5 times the tool diameter. So really, you start setting up these defaults and expressions, and you'll find that parts just go in and out of the machine with not a lot of inputs. And then what I think is almost more important is you get those defaults set up, and now your brain can start thinking about other things, hopefully work-related, but other things nonetheless. So Before I get into templates, is there any other questions?
We've got a question from Brian on defaults. Is there a way to change the default on contour selection? I want to propagate along Z to be set to off by default. Right-clicking gives me no option to save that default.
So in this, so he wants to do what again?
So on the geometry tab, to propagate along Z, he would like that to default to off.
Let's go see. So what I'm going to do is I'm going to remember that, and then I'm going to right-click and compare and edit. And I'm going to start typing propagate. I don't see it in there. So if maybe CJ or somebody could jump in and see if they know. I don't see a way to do that. First time I haven't been able to do something like that.
Well, so CJ coming in, helping out here. So just uncheck it and make all default.
Got it. I guess I did know that. Yeah. So you would uncheck that, and
yeah. And then basically just say OK there, and then make that your default, right?
So then you would go into compare and edit, and this is where CJ's saying to, I'm not sure what CJ was referring to. Where would I make all default? I know where it's at. It's right here, but where would I do that?
Let me see if I can pick that up. So so what I thought is that once that was, so that operation now has it unchecked. So if you just right mouse click and say make default, doesn't that then become the default behavior? Right there.
Did you see it?
Make default halfway down.
Oh, there you go.
So in other words, once you've tuned in all of those different parameters, you can just make that
all the default.
Yeah, that's your default format now for doing a 2D contour.
Learn something new every day. Yeah, so I've always done it the painful way. So, you know, I've gone in and out of each little thing and set them that way. So for that facing operation, what's that?
Yeah, I was just going to say, I mean, sometimes making all default wouldn't be the right thing. So I think both ways are exactly functional. Yeah.
Awesome.
And so CJ, hopefully we understood that and did that right. So just give me a yes or no, but I think we're looking pretty good there. Let's see. Yeah, I had a note coming in from Chris, but give me a little more contact there. Right click on path. Chris, I'm not quite understanding that, so if you give me a follow-up there. Brian just commented, never noticed that in the right click on there. Very nice. Thank you again. Thank you, Brian. Good questions. Okay, so yeah, looks like we're good for now. Let's keep it going.
Let's go over to template. So there's 3 templates we can go over. One of them is going to be how to what I did here is I used the template to spot drill, and tap the whole bunch. It was 150-ish, I think, about 80 holes. Also did this I call blind chamfer. So we'll start with the blind chamfer. So if you look here, if we simulated this, you can come over here and click on that guy. When you do a chamfer up against the wall, you have this kind of space right here that you can gouge. Space pot's acting a little weird, sorry. So you can see here where you're just doing the chamfer and you're not gouging that wall. So it's pretty easy to set that up, but it does take some keystrokes. So real quickly I'll show you how I did it. Going to edit. Under tangential extensions, I just do a negative. So if you had a different arc on one side versus the other, you might need to do two separate lengths. But I did a negative 70 thou, and I went in and simulated to see how close I was. Under chamfer, you want to generally when you're trying to sneak up on something like that, you want your tip offset to be a little further so you can get up next to the edge of the chamfer. So the nice thing is once you kind of get those things dialed in and down over here, I turned off my lead-in radius. So it comes in right at a 90 degree, and I actually extended my linear length. So once you get it to where you're happy with it, you just right-click on that chamfer, that operation, and you're going to store as template. So right there. I already had it in here, but if I change something, you could just right-click on it and save, and it'll ask you if you want to replace it. So we'll just say yes. So if we come down here and did a new create from template, and we just pick that from blind chamfer. So it dumps it in there. Now all we have to do is grab that geometry. I could actually do a little shortcut. I can shift and drag the geometry from there down to there if I wanted. And that just shares the same geometry. So if you have anything that you want to share a geometry with, whether it's a 2D contour, or maybe you did a 2D adaptive roughing, and then now you want to do a 2D contour, you can just grab anything, hold shift, and drag geometry down to another operation, and it'll share the same geometry. So that's how I would do. You know, if I have a handful of tools, I would do a little blind chamfer with, and set them up, each of them up, to where they kind of work really good for that chamfer tool. And then under my templates, I would have it just right in there. So when I was at L3, I had a pretty long template list, but really, really good time saver there. And we'll show you that right now with setting up a template for these drilling. So we're going to do all these odd 80 holes with this template. So the way I kind of wrote it out there was an odd 80 hole, and it's going to spot, drill, and tap in this template. If for some reason I knew I wanted to spot and drill, or let's say I wanted to spot drill just like I would spot drill those same holes, I could just pick that, and this is going to give me just the spot drill operation. But in this case, let's delete that. In this case, I want to do all those holes. I want to spot, drill, and tap them all. So I'm going to right-click in there. I'm going to right-click in the gray space, do create from template, an 80 hole, and I'm going to create all templates. That gives me that right there. So now all I have to do is right-click in there and edit. I'm going to zoom in so I can get one of these holes a little better. I'm going to go to my Geometry tab. I'm going to select the wall of the hole. I'm going to hit select from same, select same diameter. So it's pretty awesome. I grabbed all of these on the top, all of these on these middle floors here, and everything on the bottom. So like I said, that's 150 something holes on 3 different Z surfaces, and they're all 3 different thread depths. And the way I defined the depth of that spot drill is right here. So I'll come back to that. We'll come back to that in a second. And I just did a dwell. I wanted it to dwell for 0.2 of a second to have a nice clean spot drill. So bam. I think it's just a handful of mouse clicks, and we've got all those spot drilled. Now I want to share the same geometry between this and those next two. So I'm going to hold shift. I'm going to drag the geometry down. I'm going to hit OK. I'm going to hold shift. I'm going to drag the geometry down. I'm going to hit OK. So now we have spot, drilled, and tapped, 150 something holes, 3 different Z heights, 3 different thread depths. Let's simulate this one real quick. I want to show you something. We'll get in there, simulate it, and then let's come in and look at these the spot drills. So I actually left a nice little chamfer there. If for whatever reason you decided, later on you wanted that to be different, you just go right into this, change it to whatever you want. So let's say we want like a 65,000 chamfer diameter. This is where I would type in 0.65, And then it's a 120. I know that it's a 120-degree spot drill. So I'm going to multiply that by 0.288. It's a little formula I have written down. It's actually, I think it's in, if you have one of the little Haas shop notes books on page 27, if I remember right. I have some other notes scribbled on mine. But yeah, page 27 on your little Haas, pocket notes. Obviously, if you multiply your diameter times 0.288, it'll give you the number you want. So I hit enter, and I actually hit home and make that negative because I want to go down from the top of the hole down that much, and that'll give me the value that I want. So we come back to here and do stock simulation. I always like to turn on my stop on collisions. We'll redo that, and if we zoom in there, we've got a tiny little chamfer now. You can see that. So if that became our new standard, if that's what we wanted to save as a template, we just right-click on all three of those. Well, we could change anything in there, but we'd right-click on all three of them and come down, store as template, and then we're just going to overwrite that. Or we could, write a new one that said 65 thou spot drill or something like that. So we're going to hit save. It's going to ask us if we want to overwrite it. And now the next time we create from a template, that's stored in there. So those are two templates. Let's look at my notes real quick. If anybody has any questions, feel free to ask them now.
Okay, let's take a look here.
Are we looking good, Derek?
Yeah, I've got a couple questions here. Just had to get a little bit organized. So let's see. Jim has a question. I'm working in an educational environment, high school robotics team. Can I save templates, etc., to a common network, write protected location, and point to this location for the templates, etc.? Is read-only access okay for common templates, files, etc., or is write access required?
Ooh, that's so you got me all excited. In my last job, I trained people, and so we kind of had rules where you don't change tools because we had our tool library on the server. I was basically in charge of changing tools. All our templates were saved on the server. I was in charge of saving templates. So the nice thing is for me, training newer people, I had to teach them some basics of cutting metal and how to hold things, and then how to use our software. And they didn't have to remember, all these formulas for how much deeper you have to drill past a thread, threaded hole and whatnot. We're going to have to follow up when CJ jumps in with the right protection questions. We're going to have to look into that and follow up because that's a very valid question, and I think it can add a lot of value to a teaching environment.
Okay, well, it looks like
you can definitely save them. You can definitely save them. I'm sorry. You can definitely save them to a server and have everything point to it.
Yeah, and CJ is saying yes to all of those questions. It can be done. So let's see. Read only is okay. So I'd say what we can do there, Jim, send me a follow-up email, Derek at p9cam.com. And I'll go ahead and type that into the chat section here in just a moment so everybody has my email address. Send me a follow-up email, and then we'll get back to you with specifics for how to do that. Got another question coming in from Ben. How are you programming the template to drill the different depths?
Oh, let me show you that. So that's, this is where in other software I've used, it's something you just kind of slog through every time, or maybe you have a bunch of notes on your corkboard or whatnot. So I did go over how we made the chamfer diameter or the spot drill diameter. So I'll pass on that. I mean, just to kind of overview it. The way I defined the top and the bottom was from the whole top, and I went negative from there. But, that calculation that I just showed you. So the way I do the drill in this scenario, to get them all to tap at the correct depth, because this hole was modeled at a different depth than this one and so on, is the way I defined my heights in this drill. The way I defined my heights in this drill was the top is the whole top, the bottom is the whole bottom, And then I wanted to drill past the tip. And then here, the distance I drill past the bottom of the hole, because my tap, I know the tap that I have set up in there is it has 2.5 threads of lead in. So I know that I have to get that full depth thread, I know that I have to drill at least that much past. So what I do on an odd 80 thread, the thread pitch is 12.5 thousandths. So then on my drill, I generally am going to drill past that 3 times. So I type in 12.5 thou, multiply it by 3, and so that's the amount that I drill past my tap. So that's how I got there. Is that the right direction? Going down a whole nother.
Yeah, I think so. So yeah, okay, yeah. Ben just followed up. Yes, exactly.
Okay.
So perfect.
Well, I'll do that with the tap real quick. So I do the same thing with the tap. So if you go in, look at the depth, same thing here. I typed in 12.5 thousandths times 2.5 for the amount of lead in I needed for the tap, and it comes out to like 30, almost 32 thousandths. So those are the things that make the difference between, especially if you have some tight, call-outs. Those are the things that will really. Oh, I just read that note. I didn't actually select tapping. So those are the things that will make the difference between good parts and bad parts if you have tight tolerance for thread depth. So this is actually a good opportunity. I set my template up wrong. I was kind of doing it real quick before the webinar. My tapping, I didn't have it actually tapped. So I'm sure CJ and some of those guys were laughing at that. In the passive tab, you have to go select tapping. So I'll just pick right tapping, turn the dwell off. This is a good example of the templates because your processes kind of evolve as you go. So if you wanted to change any of that, you just change it and then drag over them, right click, and store it as your new template. So it's that easy to make your new template. So for someone in education, as you kind of evolve your system and you have the right, if you have the right authority, you can just write over them.
Okay.
So if that answers that, I'll show what's that.
Yeah, just kind of a couple of questions and follow-ups. So one of these just kind of go together. So Glenn was asking if the HSM shortcuts and tricks are common to Inventor and SolidWorks and all these templates and defaults. So the answer there is yes. We're showing this today in the HSMWorks, which is the SolidWorks version. The Inventor version is all of this does apply to Inventor. However, I have a comment from Nick coming in that says the drag and drop toolpaths from one operation to a new one created from template does not appear to work in Inventor HSM. So we'll need to do a follow-up on that. So Nick, what I need you to do is check your chat box. You've got my email address in there. Send me an email as a reminder. That way I've got an email in there and I can follow up and we'll get you an answer to that.
I can answer that real quick. I've already told their development team about it, and it's something that they know about. Looks like they're gonna fix.
Awesome. Okay, perfect. Brian has, let's see, question here. Multiplying a specific value by 0.288 is interesting. I'm using 2 chamfer width, in parentheses there, 2 chamfer width. Yeah. Is that basically the same thing?
So if your chamfer was modeled in, so that's 2 ways to approach it. If your chamfer, this model, the chamfer is not modeled in. So you can definitely, if your part has a chamfer modeled in, that's the other way to set your, this part's not modeled, but you would just, in your geometry selection, you'd be selecting the chamfer face, right? So definitely another way, in a good way, to set your chamfer depth. So if we want, we can go into this engraving real quick. It's another another template that I would set up.
Well, hang on a sec. Let's just finish this out. I still got I got some questions coming in here. So,
Great.
let's see. Brian's got a few here. We'll get to that in a second. Ben just had a quick question. How does this apply to Fusion? So, I mean, the assumption is Fusion is not as far along as Inventor HSM and HSMWorks. So, if it doesn't apply now, it certainly will one day, because parity on all of those will be top priority. Brian's coming in. So, to chamfer width, enter desired value, no model chamfer needed. So Brian, maybe give us a little more context there. I'm not fully understanding the question, but I think it's related here to whether or not we're entering a chamfer width on that.
Okay.
No model chamfer need. Okay, I think what Brian. Okay. Instead of 0.288 diameter, click to chamfer width and enter 0.018. So I think is actually helping us work through this rather than a question. Yeah, it's giving you an option to just put a chamfer width.
Yeah, so right there, I just changed over. So you would do chamfer width, right?
Gotcha. So I think, thanks for that, Brian. I think we'll give you panelist status here for jumping in and helping us out with that. We do appreciate it.
So that would be dependent on the however the model hole diameter was modeled, right?
Right.
So with this selection, if your engineer modeled it at your minor diameter, some engineers model it the major, some use a hole as your. So that's definitely a great tool. So you have chamfer diameter, chamfer width. Chamfer diameter could answer some of those questions too.
Sure. Okay.
Great input.
Yeah, we appreciate it. Now we're ready to move on. So Tim, we're getting close here, and I do get a lot of feedback from company owners out there. At 1 o'clock, they like the guys back to work. So let's see what we can do.
So real quick, we'll do this engraving here. So on the back side of this, all I did to set up that job was I did a Control-D. There's 100 ways to do everything, right? So I did a Control-D, I deleted everything I didn't want. I just went in and reselected my work coordinate to the other side. I did continue machining from operation, and I would have changed the program name or whatever I wanted there. So that's how I got the other side of the job. And then I did generate toolpath, so it just generated the toolpath on the other side. And then the way I did the engraving here is I'll save that as a template real quick, store as template, and I'll just type in engraving. Is I do create from template, engraving. So I probably would have named it what my engraving tool was, or the type of engraving. But in here, you just right-click and edit. In your geometry tab, you can just grab the engraving right out of the tree and hit OK. So because of the way I had it set up, if you do common things like engraving or roughing or whatever you want to save as a template, it's just a few mouse clicks to duplicate that over and over and over. So you can see right there, you got a nice engraving there. So I had a whole list of other stuff we could go over, but I would say let's cut it off now. It's probably a good place to start or stop.
Okay, it sounds like we've got some material for a part 2 on productivity tools.
Yeah.
Excellent.
Yeah.
All right.
Kind of my favorite subject.
Yeah, and this was a great presentation. I think everybody got a lot of value out of that, so we do appreciate that. So thank you, Tim Paul, application engineer from Autodesk. Also, CJ Abraham in the background there, also an application engineer from Autodesk, jumping in and giving us a lot of help. We also had Wayne and Michael in the background there helping out. We do appreciate it, guys. To all of you out there, thank you for spending this time with us. We do realize it's an investment in time, and appreciate you being here. So this is Derek. I'm from P9CamSolutions.com, and hope to see you on the next one. Thanks, everybody.